Hey guys, so we left off talking about titration equation and how to use it for neutralization of acids and bases. And for the most part, we did problems that were involving a monoprotic and monohydroxy base. So that means like for every one proton you have, it kind of like cancels out or neutralizes the one hydroxide base that you have. So it was really easy for us to figure out moles of acid equals moles of base for neutralizing using the titration equation. We're now going to look at problems that have dihydroxy bases, meaning it has two hydroxides in one base, and diprotic acids. You could even have more than that. You could have potentially triprotic acids or further. So let's get to it. So just to quickly recap, we have so far been using this equation where the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. And based on our previous video, we saw that M times V is the same thing as saying moles. So really the moles of the acid equals the moles of the base when you are at your equivalence point. That means when you are neutral, because you have the same amount of acid as you have base. So, and we went over this problem already together. This is where we had a single hydroxy base, so this is a monohydroxy base with a monoprotic acid, which means we have one hydroxide in our base and one proton in our acid, so they easily are going to kind of cancel each other out. Okay, so monoprotic, again, it just means an acid with only one proton on it. So a polyprotic acid is an acid that has more than one proton. Could have two, could have three. Specifically, if you say diprotic, it means it has two protons. Triprotic means it has three protons. And so here are some examples. So HF, hydrofluoric acid, is considered to be a monoprotic acid because there's only one H, only one proton. Whereas phosphoric acid has three protons. So this is like 3 for 1 kind of deal at the grocery store, where you have 3 protons for one molecule, and here you only have 1 proton for one molecule. You could also have sulfuric acid, which has, this is diprotic because there are 2 protons on this acidic molecule. Monoprotic, triprotic, diprotic. And these are both considered, the triprotic and diprotic, to be polyprotic, meaning, again, it just has more than one. Okay, so here is a little adjustment to our titration equation. If you have, let's say, an acid that has multiple protons, then you are going to have to multiply the side of the equation, Ma and Va, by the number of protons that acid has. Likewise, if you have a base that has multiple hydroxy base, then you're going to have to multiply that side of the equation by the number of hydroxides the base has. So let's do a problem. So here we have 42.5 milliliters of 1.3 molar potassium hydroxide, and it's required to neutralize 50 milliliters of our sulfuric acid. Find the molarity of sulfuric acid. So we're going to do the same thing as before, where we're writing our acid information in one column, and our base information is going to go in the other column, and then we'll plug it into the equation. So we know that sulfuric acid is the acid because, again, it has the hydrogens up front. And we know that hydroxide, potassium hydroxide, is the base because it has the OH in it. And now we are in a situation where we only have, this is a single base. It has a monohydroxy base, only one hydroxide in it. But our acid actually has 2 protons, so this is a diprotic acid. So this is like twice the bang for the buck, and this is only going to count once. So this guy's going to count twice. Alright, so our goal is to find the molarity of our sulfuric acid, and so we don't know the concentration of the acid. We do know the volume of the acid because it tells us 50 milliliters. For our moles, we know that we have 2 moles of protons because there are 2 H's right here. So now we need to incorporate moles of the protons, and for the base side, moles of the base. Oops. So on the base side, we know the concentration is 1.3 molar, and we know the volume is 42.5 milliliters. And we know the moles, or the amount of hydroxides there are, because there is only 1. If there were 2 or 3, it would be in parentheses, and then there would be a subscript on the outside. So we know there's only 1 because there are no parentheses and subscripts. There's 1 oxygen and 1 hydrogen. Okay, so we have all of our information, our new and improved equation, our concentration times volume times moles. This is the acid side, and this is the base side. So I'm just going to plug in everything. So I know on my acid side, we don't know the concentration, so that's our X. We know the volume, and we know our moles of protons is 2. And then that equals the base side, where we have all the information on the base side. So it equals 1.3 molar, 42.5 milliliters, and 1 mole of hydroxides. This is supposed to be on the same line. I just ran out of space in my PowerPoint, so they're not being divided. They are equal to each other. So you're solving for M, which is your X. So because M is being multiplied by this side, you are going to have to divide 50 milliliters times 2. So you're going to have to divide 100 from the left side and 100 from the right side. And when you do that, you should get 0.55 molar H2SO4. So you just calculated the concentration of sulfuric acid that you need to neutralize the amount of base that you have. So nicely, the moles took care of any thinking you had to do. So you didn't have to worry about thinking about how this is diprotic and this is monohydroxy base. It just does it for you. So going back to our worksheet from the last video, we're going to try and do some problems. So now you'll see for number 7, it asks how many milliliters of 0.360 molar sulfuric acid are required to neutralize 25 milliliters of barium hydroxide. So we know that this is the acid because it has the H's right in front, and we know that this is not monoprotic. It is diprotic because acid, and we're going to say moles of 2. It has 2 moles. And I'm going to add N to both sides of my equation because that is our new equation, is to have moles in our titration equation. So we have 2 moles of acid because there's a little subscript 2 next to the H right here. So we know we get 2 protons off of our acid. And for our base, there is also a little subscript 2. So we also have a dihydroxy base. So I am going to write N equals 2 and base. And we know this is the base again because there is the OH in it, so that is our hydroxide. Alright, so let's plug in stuff into the equation. So focusing on our acid side first, like we said, we know we have 2 moles of our acid, so that is going in the N spot. We know that our concentration of the acid is 0.360 because it's right here. It's the capital M. That 6 is really bad. And then our volume we don't know. It says how many milliliters. So we don't know our volume. So I'm going to just put an X there. On the base side, we know the concentration. Again, capital M goes with the capital M over here. So we have 0.1 molar for base concentration, and our volume is always measured in liters or milliliters, anything with liters. So that is our 25 milliliters, and just to quickly check, the answer also asks for milliliters, so we don't have to worry about converting. Oops, so here we have our 25 milliliters for the volume of the base, and the last thing is to multiply by moles of base, which we said was 2, because again there are 2 hydroxys right there. So multiply that by 2. Nicely actually, so we're solving for x. Again, everything is being multiplied on both sides. So to get x by itself, you're going to have to divide this stuff out. So 2 and times 0.360. So that will cancel on this side and divide this by 2 and 0.360. And you can, of course, you could just plug this into your calculator where you have 0.1 times 25 times 2 divided by 2 times 0.360, making sure that the bottom all is in parentheses. Or you could also see that you're gonna divide 2 by 2, so you could just cancel that right away. And then just plug this part in your calculator, 0.1 times 25 divided by 0.360. And you get your x is equal to 6.9. And again, for units, I want to go back to see what my problem asked for. It asked for volume of the acid, and the volume of the acid is going to be in milliliters, not just because they're asking for it in milliliters, but because when we plugged in volume on this side of the equation, it was in milliliters, so our answer for volume will also be in milliliters. So we have 6.9 milliliters of our acid, because that's what we were solving for, which is H2SO4. Yeah. So I would like you guys to try number 6 right now, and in the video I will ask for your answer in just a second. I wrote the equation for you, so your moles of acid times MAVA, moles of base times MBVB. So take a second to answer number 6 for yourself. So you should have gotten this setup where you have your moles of acid is 2 because sulfuric acid has 2 protons in it, times the concentration of acid is what you're looking for, so that's your X. The volume of the acid is 125 milliliters, equals the moles of your base. You have 2 hydroxides. Again, I know that because there's a little subscript 2 on the outside of the hydroxide, telling me I have 2 of them. So 2 for moles of base times the concentration of base, which they told you is 0.5 molar. I know that's a really bad decimal, but that's a decimal. 0.5 molar times 50 milliliters. So that's your setup. You solve for x by dividing from this side 2 and 125, which you do the other side as well. And once you have solved for x, you will find that your answer for concentration of your acid is 2 molar of your H2SO4. Again, I know the units are molar because that is how you express concentration.